Plutonium. It's an essential metal with unique properties and a somewhat dark history. It's a deadly element capable of destroying all of humanity in a fraction of a second. This element, like uranium or any other metal, is not naturally found in the world. Instead, plutonium is man-made. Once again, humans have ventured into inventing something without awareness of the consequences. As you know, many elements have been discovered for years, but plutonium wasn't discovered. It was created in the United States in 1940. However, the first question that comes to mind about this element is about its shape. Plutonium is a silver-colored metal, appearing similar to other metals, but with a significant difference. It's really, really dangerous. One of the reasons for the danger of plutonium is that atomic bombs are made using this element. Another reason is its high toxicity, caused by being one of the most intense radioactive materials. When they were constructing the first atomic bomb at the Los Alamos National Laboratory, known as the Manhattan Project, they used plutonium. They were aware of its strong radioactivity, and workers tested plutonium in sealed boxes with gloves and masks. If you want to know more about the danger of this element, it's interesting to note that one of the lab workers had a slightly damaged glove. A tiny amount of plutonium came into contact with his hand, and although he quickly cleaned his hand and was rushed to the hospital in great distress, doctors found that he was contaminated with plutonium, but not to the extent that he would get sick because he cleaned his hand very quickly. He underwent various tests every week to ensure he didn't develop cancer or any specific illness. In all the tests, plutonium was found in his blood, but he remained healthy. However, the plutonium in his blood did not disappear, and it stayed in his bloodstream until the end of his life. Now, if you are informed about the danger of this element, let's see how plutonium is made. Plutonium is produced in the fuel rods of nuclear reactors. As you may be aware, uranium has an atomic number of 92 and can transform plutonium with an atomic number of 94. The specific uranium isotope involved in this process is uranium-238. To simplify, uranium-238 captures a neutron, resulting in its transformation into plutonium-239. Plutonium is a highly dense and sturdy metal, making it challenging to work with. Working with this metal is difficult because it is so dense that handling it poses significant challenges. This metal, packing such a hefty density, has a rapid meltdown. The melting point, pretty low, precisely at 639 degrees Celsius. Considering its density, that's exceptionally low. Now, check this out. Let's stack it up against iridium, one of the densest metals on the planet. Iridium's melting point is a scorching 2446 degrees Celsius. See, plutonium gets a bit wobbly when things heat up. Iridium is super dense, right? But guess what? Osmium takes it up a notch and gets a tad denser. Now, brace yourself for this. Osmium's melting point, well, it's a whopping more than 3000 degrees Celsius. Trust me, I'm not trying to overwhelm you. We're on this learning journey together. Stay tuned, and we'll be diving into it in future videos. But let's get back to plutonium. Plutonium is so radioactive that it gives off heat. You're not supposed to touch it, but if you were to touch it, you would feel a hot piece of metal. When plutonium starts to decay, it gives off helium. So, if there is an old piece of plutonium in a container, there will be helium gas around it. And when it's giving off helium, it's making the metal weaker and weaker. You could kind of compare it to metal rusting. And that is why when plutonium is used in places like this, they have to make sure it's perfect. Another thing that makes plutonium extremely dangerous is dealing with plutonium waste. To do this, there has to be a specific container that could handle a lot of pressure. If it's not like that, it will explode. As you remember, plutonium gives off helium, creating pressure in a container. If the walls of a container are weak, it will blow up and radioactive waste will go everywhere. There is an interesting story that I like to share with you. Alpha Matic, a UK chemist, was working on the atomic bomb during World War II. At that time, he only had access to about 10 milligrams of plutonium. Unfortunately, he spilled that 10 milligrams of plutonium on the desk. He gets bummed out, not because there's dangerous material on his desk, but because he wasted all the plutonium they had access to and they needed it for the bomb. How is he gonna collect it back? He immediately brings a handsaw and cuts the table around the plutonium. Then he puts it in a furnace, places a container underneath it, and sets it on fire. He burned the wood, so the plutonium would be separated from the wood. He separated the ash, and he once again had the plutonium he needed. By doing this, he loses 0.5 milligram of plutonium, so he has about 9.5 milligrams left. It's good to know that when they're working on plutonium, it's in liquid form. Also, it's good to know that plutonium gives off light, and just like other radioactive metals, it looks very cool in the dark. It's kind of like those watches that glow in the dark at night, but there's no plutonium in these watches. They use a gas called tritium, which comes from hydrogen, and it glows in the dark. Let's delve into the origin of the name plutonium. If you know, the uranium name came from the planet Uranus. Following Uranus, there's a planet named Neptune, and on the periodic table after uranium, you'll find the element called neptunium. Beyond Neptune, there's a dwarf planet known as Pluto. However, during that period, Pluto was considered a planet, and that's the reason they named the metal plutonium. Clearly, you can't just go out and buy or sell plutonium. Nevertheless, transactions involving plutonium must occur somewhere, especially between governments. To acquire 1 gram of plutonium, you'd have to shell out approximately $4,000. Since plutonium doesn't naturally occur, you need to transform uranium into plutonium, hence the hefty price tag. Now, let's explore the intriguing realms where plutonium finds its most prominent applications. First, in nuclear weapons. According to the Royal Society of Chemistry, 1 kilogram of plutonium can generate an explosion equivalent to 10,000 tons of chemical explosive materials. Nuclear treaties aim to prevent the use of these devastating weapons. Second, in space heaters. Components in spacecraft operate most efficiently at specific temperatures. Plutonium-238, when undergoing decay, releases a significant amount of heat. This heat generation assists in keeping delicate instruments warm in deep space, and also in power generation. The heat produced from the decay of plutonium can be absorbed and converted into electricity. According to the World Nuclear Association, 1 kilogram of plutonium can generate 8 million kilowatt hours of electricity. If you enjoyed this video, be sure to give it a thumbs up and subscribe. We have plenty more thrilling videos like this waiting for you on our channel.